Okay, so hi again, I'm Luka, this is Ivan. First of all, thanks to Debug and to WeAreDevelopers for inviting us to talk today. So what we will try to do today is share some of our experiences when it comes to IT architectures. We'll also try to give some recommendations about what to do and what not to do when you're designing an architecture in a larger enterprise environment. We'll try to give examples where we can from our own experience. And you will see, we will cover actually several topics. So feel free to ask any questions if, we go across one topic too fast. Because as IT enterprise landscape is quite large, there's also large number of topics that we want to share. So, okay, let's start. So, actually, what is an enterprise IT landscape and how does it look like? You probably guess that it's big. Ivan and I, we work in telcos most of our careers, which is a really big IT landscape. But just to make it more clear, I'd like to compare it with buildings and let's say neighborhoods. So it looks like something like this. You know, it's big, it's modern, it's neat, it's beautiful. I'm kidding, of course. It doesn't look like that at all. Probably only chief architects think that it looks like this. Actually, it looks something more like this, or this, or this, if you're lucky. The reason is that most enterprises have been building their IT for the last 20, 30 years and doing it mostly by adding new systems on top of existing ones. Rarely decommissioning the old ones. So now you have a really big combination of really cool and modern stuff and some really uncool and older stuff. That actually makes it really interesting, but also challenging. But what happens at one point, since you're building one thing on top of the other, it starts to crumble, and you actually have two choices. You need to change something, or as you like to call it these days, do a transformation project. And you can do it in two ways, basically. You can go all in, do it big bang, change 80% of your landscape, or you can do it progressively. In our experience, I have done one transformation that was a big bang approach. That's actually first don't do big bang transformation projects. Try to do it one step at a time and progressively, if possible. So how can you do it? Well, first you need to identify what are your biggest pain points. What is the thing that is more troubling your business with the current IT landscape? Then think of a better way to doing that. When you do that, take a step back, because you're probably already gone too wide and you're looking at a project of 3 to 4 years. You can't do all of that. Do a minimum of what you can think of, but that it makes sense, that it really solves the biggest issue that you can, and that you can integrate it with the existing systems that you have. So in order for you to do that, there are actually 3 things that you need to consider and have in mind. For us, in our experience, microservices architecture is a must in doing that. Why? Not just because it's a hype and everyone is doing that, but because, and you can also read this in a lot of books that talk about microservices architecture. It's, as people say, so done right. It's finally we have the technology and the means to do service-oriented architecture in a good way, to make it scalable and maintainable. So that's why microservices architecture is a must. But when you can really do a lot of good or do a lot of bad is in integration part. So you need to be smart when it comes to integration patterns. And also, as in all development, you need good development practices established. Otherwise, you won't be able to build anything. So those are actually the 3 areas that we will try to cover in our presentation. First, the microservices architecture. The main message that I want to convey here is that microservice isn't a Spring Boot application. Now, don't get me wrong, I have nothing against Java Spring Boot. I like it actually, but many times I've seen someone build a Java Spring Boot application, deploy it on as a Docker container, and says, I have a microservice. You don't have a microservice unless that microservice has data. When we come to the definition of a microservice, in its essence, it's a small autonomous application that can handle one domain independently. Autonomous and independently. You can't do that if you don't have data. You can't do that if you're creating a facade or proxy microservice that keeps data in legacy and is querying that legacy for all data. I mean, you can do it, and there are uses for such applications, but you can forget about any kind of performance or scalability if you query an existing legacy backend systems for every time someone queries your API on a microservice and needs to get some data. That's the most important thing. We will talk later, Ivan will talk about what are good ways to get data out of legacy and into a microservice. So I won't go into that, you'll hear that later. Other thing that is important is how you design your microservice. What is important is a lot of times people have a set of functionalities, you put it in a microservice and you just go from there. It's a great way to build a microlit. What that means is build a microservice that's actually a monolith, just you deploy it on Docker and you call it a microservice. In microservice design, you should really look at domain-driven design. That's an older concept. You have great books about it, especially the part, you have a book by Eric Evans, Domain-Driven Design, when he talks to bounded contexts. What that means actually, in a nutshell, is that when you design a data model for an enterprise, you can't design one data model that will work for the entire enterprise, because that's it's actually not how an enterprise functions. For example, you take a customer entity, and you talk to finance, you talk to sales, you talk to customer care. Each of those departments look at the customer differently. In finance, they look at, did he pay his bill and something like that. In sales, they look at what services is he using, can we upsell, cross-sell, something like that. In customer care, they're looking at, does he have problems? Does he have problems in the past? What kind of problems, etc. So the models are not different. And what you need to do is you need to establish a boundary in which your model is unique. And that is basically in one domain, you could have one model that is unique. And then when you talk to another team or whatever that is designing another domain, you need to establish what the boundaries are exactly like and what is important, how to transform and connect your model with their models. It's really a good concept. I won't talk any more about it, but you should look at it. You have really a lot of materials online about that. So the next topic, when it comes to microservices, actually this is one of my favorites, and also a lot of debate is around that. When it comes to the communication patterns between microservices, how do they communicate with each other? There's actually two big patterns. One is choreography, the other is orchestration. Choreography, you have microservices that are independent. They function as, let's say, individuals with a set of rules in which they talk to each other. But there is no central microservice or whatever that is orchestrating them. In orchestration, you have a central entity that is orchestrated, that is telling the other microservices what to do. Which one is better? Neither, because it depends on the use case that you have. Mostly in whatever you're designing in IT, there is no one size fits all. You need to be open-minded, and you need to look at the exact use case that you have. So, for example, choreography is really great. It is actually my preferred method because in choreography, the main benefit is that these microservices are completely decoupled. When one goes down, it doesn't influence the rest. If you need to remove one microservice and implement it in using a different technology or whatever, you can do it because they communicate asynchronously. They have a set of interfaces that are standardized, and this really gives you a lot of flexibility. But what is the problem with choreography is that if you have a complex system or a complex process that you need to implement, it's really hard to visualize the communication. So if you can't visualize that communication, don't use choreography. You can visualize it by using open tracing and technologies like that. There are ways, but if you can't do it, don't go into choreography. Orchestration, on the other part, is great. For example, when I used it in order execution process. When you have a process that is sequential, and you really need to follow the exact amount of steps that are needed to finish it. For example, in telco, when you do order execution, you need to create a customer, you need to create his assets, you need to send his equipment to the delivery service. You need to talk to other telco operators regarding number transfer and stuff like that. You need to activate subscription for that customer in billing. There's a lot of activities that you need to do. All of those can be implemented as different microservices, but when you orchestrate, you're really sure that everything is happening the way that it should. But you shouldn't do orchestration in code because the same as choreography, you won't have any visibility of that. When you do orchestration, my advice is use a BPM tool. You have really good BPM tools on the market that you can use, and the visibility and the control of that process is great. So just to show you, this is one BPM tool, and this is how it looks like. You have here are the process instances. Some are in incidents, some are not. So it's really a good way to see what is happening in that process. If something is in incident, you can easily see what is happening. So the level of control here is really great. So that's my advice when it comes to orchestration. But the most important part is no one size fits all. So let's move on. Just some quick best practices when it comes to microservices design. Actually, the only don't here is don't put everything in code. Use the technologies that are on the market and that are really great. For example, if you have a lot of business rules that you need to implement, there are great rule engines that are fast and that you can use instead of writing millions of ifs and cases in your code. The only trick here is if you're using a rule, if you are using an, there are two ways you can use the rule engine. You can embed it in your code, and then it's great. You just use the engine and embed it in code, or you can build it as a independent standalone service. But if you do that, it's important that it's pass-through, that the rule engine only executes rules. It doesn't query any database or backend or anything for data. It should look something like that. This is request, this is response. You give him the rule that it needs to execute. You give him the data, and then it executes the rule and gives you the response back. And it should be in memory, and it should be really fast. As you see here, it should really be number of milliseconds that you can count on your fingers and toes. Because if it's slower than that, you can forget about any kind of performance that uses the rule engine. So it's really important that it's passed through, it's in memory, and it doesn't query anything. It's just an engine. Also, use artifact repositories. They're really easy to use, really beneficial. Use tools for logging. Don't log to file system, database, and then if you have an incident, spend 3 hours querying that. Use tools that are on the market for that. The same as for monitoring. Use time series databases because they can handle a lot of data and they have great visualization tools that you can look at in the operations part. So I'm not going into specific technologies that you can use, but for all of these technologies, you have open source solutions. If you want to know, I can tell you what we are using, but maybe later on or in the question space. And the last, but probably the most important thing is work together with business, because a microservice or any software that is its own purpose doesn't make sense. So you should build it together with the people from business, and you should build stuff that really solves some business issue. That can be some new capabilities or functionalities. They can be just that you are doing refactoring, transferring some old implementation into microservice because you want better performance, which will result in better customer experience. These are all valid reasons, but don't do it without talking to business and having a really good valid reason. Because basically microservice should be analog to a business domain, and it should implement business capabilities. So that's really an important part here. So that should actually be the first step when you're designing the microservice. Know what is the challenge and what are the capabilities from the business side that you need to solve, and then go to the technical part. And that's it about the microservices architecture. I will now give the word to Ivan, who will talk more about integration patterns.
About integration patterns. So when we were doing this kind of migrations, basically integration as you move to microservice, integration becomes more of a hot topic than it was before. So some of our experiences is don't use multi-layered API flows. What I mean by this, we have a situation currently where front-end is calling backend, that is calling second backend, that is calling third backend, fourth backend. So basically you have this connection of flows where each layer is introducing their own bottlenecks, their own slowdowns. So don't do this. Second is what Luka also mentioned in microservice architecture. Try to do domain-driven design. In telco industry, where we are happy that we have a global guidelines regarding this, there is a community gathered around TM Forum, Telemanagement Forum organization, that already built for us some models. So we know what are the customers, what are the products, what are the services, resources, payments. So we already have domain-driven design that can be followed. Basically, we already have a domain prepared that just need adjustment for a specific telco. And this domain is extensive enough so that you can extend it without, let's say, many troubles. Of course, no-brainers. Don't use non-scalable or low performance. By non-scalable, I mean try to not reach the limit where you need to pay for extra licenses or where you are on older technology that you cannot horizontally scale. I mean, you can always add more CPU power, but this is something that needs to be avoided. And also try not to use non-documented APIs. I know we had cases where there's an API working for 10 years, it works good. It's just that developers that did it a long time ago left the company, and you don't want to rely on such API, because when problem starts, then you will need to redesign that API in a matter of hours just for it to work. So if you have something that is old, and I mean in telco we have a lot of old technologies that are there because they work, and we have systems that are old 10 or more years. You have stuff that is not documented. So what to do in integration patterns? Try to use data provider APIs. So if you cannot come closest to the data by querying the database, try to come to the layer that is closest to that database layer. In some cases, you have some off-the-shelf solution where it is a black box. You only have the API provided by that solution. No one is telling you, okay, in the transformation, let's replace it. You purchased it, you want to have a return of investment over it, and basically you should use it. But you don't want to use first API that is calling second API that is calling this COTS API. Try to consume it directly and then use rule engine to apply any rules on transformation that you have over data to provide domain-driven domain data that is needed for that particular purpose. And try to do something that is try to rely on something that is easily upgradable to new principles. So if you have old API, that you see, okay, we need to spend a little more effort to be compliant with the new proposals, new strategy, invest in that API, clean it out, and upgrade it. Don't build everything from scratch. But of course, when you have 10 or 20 years of development, a lot of things are piled around. So sometimes you just need to have a clean cut and do it from the beginning. Regarding the integration patterns, we found, let's say, something like five patterns. I will present some of them here. And what is important is that one pattern doesn't fit all. So first, when we are trying to figure out the patterns, we first split it up by CQRS principle. When we looked at our logs and how users are accessing our data, most of the data access is read access. So a lot of people on self-care devices want to see what is the state of their consumption, are they paid, have they been paying the bills and stuff like this. So most of the data is coming from telco to the customer. And then you have a payment of bills, activating some new add-ons, changing tariff, and this is the smaller amount of command-like queries. So basically, one pattern will not fit all. Try to separate your integration patterns and your APIs by CQRS principle. Do stuff in async. If you have problems with executing the commands, give the user the info, okay, it is your request has been received, and do it quickly. And then later on, if you have 5, 10, or 20 seconds where you need to process this data, as Luka mentioned, our orders are complex. Sometimes we go from creating the customer to checking the DSLAM to see if the speed is good enough so that he can receive some HD channels. It takes some time. So try to do it in an async way and try to keep it simple. So these are some of the patterns I will share with you. So this is the CDC, or data replication pattern. So we have legacy backends, legacy APIs. What we are trying to do is copy the data from these databases to a replication database, and then do a data transformation from legacy model to a new domain model. So in legacy, we often have situations where in some applications there is a mix-up of many models. We have, for example, customer data in 5 different databases. So this shouldn't be the case in the domain-driven design. So what we are trying to do is pull this data as fast as possible through the data replication layer, and then transform this data to a domain-driven data. And then when front-end is querying your microservice, you have data already prepared in the model that is by the domain-driven design. And what is important here, data replication, it's not only a CDC. So depending on how often is the data changed, how often users needs to be aware of this data change, it can be a batch job, it can be a nighttime job. So basically, it's up to you to see what fits your purpose and how will you do the replication. CDC is only one of the options that is applicable. The second pattern that we saw is when you have off-the-shelf solution, or where you need to consume something not directly from the database. So how we did it, for example, in our case, this is the user consumption API that is connected to different billing systems. And this data is changed really, really frequently. CDC and amount of data that is coming through the mediation systems, it's really big. So CDC would just introduce the overlay that is not good enough. So what we did, first we simplified the architecture. Currently we had these multi-layer API flows that were introducing their own timelines and bottlenecks. Now we connected either directly to the database, or where we had off-the-shelf solution, we connected to a SOAP services that off-the-shelf solution presented. And then we are doing the querying these solutions, transforming it in a specific service layer, and then presenting it to the customers. Of course, I put the cache here because usually users don't want to see every second what their data consumption. So you can put this kind of data in a cache for 10 or 15 minutes. 10 minutes should be enough for users to, let's say, if he wants to return to the consumption data, he can check it out. But also you need to be aware of you need to sometimes give him a pull to refresh capability. If he really wants to see data exact in this time, you can do it by demand. But most of the users, just when log into the self-care app, they want to see the current consumption. And if they jump over to the details, you already have this data in the cache, and you can show it to them. Okay, and the third layer is what I was mentioning regarding the commands that are being executed. Basically, if you have a situation where you are executing, for example, changing the tariff of a customer, and this takes some time because processes needs to be run, you need to connect to all those legacy systems that are responsible for changing the tariff from the, let's say, BSS layer to OSS layer. Sometimes this takes time. So try to see what are the transactions that you have minimal number of errors of. So if you have a change tariff process that is really, if qualification of what tariff user can jump into is really good and fast, then your execution part will mostly be successful. But if it's slow, you can use the pattern where you store the message, you tell immediately to the user your request has been stored, and then you start this in a synchronous way executing this message. When this is successful, send a push notification to the user. So we have self-care applications, we have SMSs, we can send to the user, now your tariff has been activated. So try to use where you see that you have a really higher percentage of successful executions, try to do this in an async way. Okay, so other things regarding data aggregation and data consolidation, don't do it on demand. So this is more, let's say, applicable to backend for front-end layers or front-end closer APIs. Don't try to do on-demand or on-fly aggregation of domains. Try to set up a domain and prepare it how you see it is fitting. Don't try to do aggregation over many domains. It really means that you did something wrong. If you need metrics, if you need aggregated metrics, try to prepare it in advance by relying on event-driven messages. So instead of querying the database to see, I don't know, how much SIM cards customer has, you can do, once he's activating a new SIM card or something like this, put this event and store it somewhere in the bucket. And then when you want to know how much SIM cards he has, query the bucket. Don't go to the database and try to query select counter from number to return number of SIM cards. Also, if you have situations where some of the microservices are sharing the same database but in a different schema, don't try to consolidate data on the database level. Database should be treated as private fields. So they are owned by a microservice, and there is a layer of business logic above this data where perhaps when you are querying some data, you won't receive a correct response. So if you need to aggregate something, prepare in advance, do it in advance, and don't do it on the fly, especially directly on the database layer. It is okay if this is done by data warehouse. This is their job, but I'm speaking about direct consummation of data from digital channels, from self-care apps. Also regarding the microservice approach and APIs, try to do some sort of management. This will really make things easier. So you have free API management tools. You have a really expensive one. So depending on your budget, try to fit something, but it is really important that over your APIs, you know who is technical and business owner, you have the governance, you know when a new version of API will be set up, you know when old version will be retired, you will know who are your in some cases, we needed to introduce throttling to find out who are our consumers, because some people we didn't even know were consuming the PL SQL procedures started complaining about timeouts. So API management, where you know what is the current version of API, where you know who is consuming it and who is the owner of it, this is a way to go. Don't treat APIs only as one protocol API. So this is what is the domain and layer separation. Domain separation is domain-driven design separation, and layer separation is try to keep things controller, service, and repository to keep them out of each other way. So every layer has its own boundary, and that boundary shouldn't be crossed. If you manage to do this, then it's not a problem for you to have an API that has repository and service, and then it has controllers towards REST, towards gRPC, towards Kafka or other streaming platforms. So try to separate it both horizontally and vertically to have a clean architecture. Regarding the development practices, so I try to split them up by organization level and team level. So in order to have a good development and good APIs, some rules on the organization needs to be setup. It's okay in smaller companies when you have a small team and startup, you are creating your own rules, but on organization level, you need to have support from operations department. You need to have support from DBA, from system department. So some rules needs to be set up. What you don't want to do is to have multiple tech stacks. Try to find the tech stack that is okay for you and try to stick out with it. You don't want to get yourself into a situation where some developer developed microservices in, I don't know, Kotlin or Go because it was really hype technology for him at that time, and then he left the company. Who will govern this? So try to have a tech stack that is, let's say, future-proof, and that you see it is really something used in backends. On backends, we are, let's say, lucky here. We are not as volatile as, for example, JavaScript frameworks. We have Java before, we have Java now. It's just we have different flavors, but this is it. Also, try not to limit the tech stack in a way that, I don't know, if you need something where you see graph databases will be good, don't be limited by, okay, do it in the Postgres or something like this. Don't do legacy tech development. I mean this in a transformation. You are trying to move your team also from old technologies to new technologies, and you have a bunch of experts on old technology, and they are juniors in new technology. And sometimes when you have deadlines, decision will be, we can do it in 30 minutes in old technology or in 3 hours in new technology. Invest in new. First time it will be 3 hours. Next time it will be 2.5. I mean, no one learns skiing in 30 minutes. So you need experience. You don't want to go back because then you achieve nothing. Don't skip continuous integration. I know that for enterprises such as ours, continuous delivery where you push your code to production is usually a no-go, because we want to have human unit acceptance tests. We want to have deployments to production over several systems that needs to be synchronized. So it's okay to split CI and CD, but don't skip CI. So have a DevOps that has minimum CI at least, that is running automatically, code reviewing, unit tests, and whatever tests you put in the code. Don't do a constant move forward. So we also had experience where new user stories are just arriving, and you didn't manage to have time for optimization. I don't mean just small optimization when you are solving some visible technical debt, where you put something in the commit to do, and then you find some time in the next sprint to fix it. I'm talking about getting the overall picture seen. So as a developer, I learn every day. I find some blog, I find some new technology. So we constantly move forward. So 6 months from now, I will be smarter regarding some things that I am currently. And currently I did some code. So 6 months later, perhaps I need some sprint to sit down to look the overall picture and to see, okay, what can be optimized, what I learned in the last 6 months that can help me move further. Otherwise, you will just have, let's say, clock that all parts are working, but it's still showing wrong time. And try to have a clear member roles. Try to have a governance that is known when exactly something is expected. Developers like to know when they have meetings with their product owners. They want to know up until when the user story will be groomed and finalized, so that they can start development. So Scrum is a really good principle here, because you can set up the deadlines. You can set up when is expected, what is expected, and what amount of work needs to be done in the next 5 or 10 days. So on the organization level, try to stick with these principles. Try to have this in a dedicated time slots so that developers can plan. This is the greatest thing that can be done when you have the sprint and when you have the agile approach. On the team level, you want to have guidelines, especially when you're doing digital transformation to something new. You need to create the guidelines. You need to tell either to, let's say, new technology junior developers or some senior experts that you hire, but where they don't know the telco stack. You want to have for them the guidelines, how things are built. So, for example, we have our horizontal splitting up several projects where it is known what each project does and what kind of code should be in some kind of project. So this is a guideline that is really helpful to a team. Don't prioritize deadline over tests. This is easier said than done, but what I would suggest is never communicate to business how much time you need for writing only code. When you're writing code without tests, you don't write code. You're writing a wake-up call in 2 a.m. by operations team that something is not working in production. So you are the ones that will be called when something is not working, not your stakeholder. And in my experience, as older you get, you are much, let's say, much less open towards this kind of calls. Try to do code reviews and try to establish coding practices. So this is basically the constant work. So you need to, on the team level, to have retrospective, to have feedback from your team, what was good, what was not good. This is the only way how team will work on. And you need to also do a knowledge transfer. So basically, it's not just knowledge transfer to a new team members. It's knowledge transfer when you found something, you read some blog, you found something that can work. Unit assertions, you will do assert J or Hamcrest. So basically, when you find something that will speed up the team, you have some R&D time in the sprint, because this is how you move forward. Also, regarding the library dependency management, it is okay to make a tech stack, but you will run into problems where you have one library in Spring Boot 2, you have second in 2.1, 2.2. So when you start connecting them together, things will break out because there will be inconsistencies. So try to create a project that will have your bill of materials of dependencies, and then try to agree, okay, let's use this for next quarter, and then after 3 months we will see what has been upgraded and then move forward. Enterprise are, let's say, a bit slower here because they are not always let's say on the latest, on the edge technology, but this can also be good because you can check, you can leave others to solve the initial bugs that new version of technology brought. So you can be much more, let's say, on the safe side here. Also, what I wanted to show is basically do the unit tests. They are really helpful when you are moving forward and you are doing this dependency upgrade. If you run your unit tests when jumping from Java 8 to Java 11 and everything passes, you will be sure that, okay, this can work. So this is, let's say, a really important thing to do. So this is it from my side. I can't do it without pause. So we are now open for any questions that you have. I see there is only one question regarding the videos.
Okay.
Yeah. And
so I'm back with you guys. Okay, let me publish question number 1. Will those videos be available afterwards? Yes, they will. If the question refers to video of this session, yes, video will be available at WeAreDevelopers website and then bug website. So in maybe 2 days. Let's see another question. Do you recommend using GraphQL, guys?
Okay. Will you?
Yeah, GraphQL is great. I think I like it a lot, but for frontend, to me that's backend for frontend pattern, and then there you should use GraphQL, and it really makes sense, especially when it comes to performance. But when it comes to internal integration between various systems in the landscape, there are some other protocols like gRPC or REST, like everyone uses. But yeah, I don't know if
basically for me, GraphQL is really a good technology to do in backend for frontends. Backend that is as closest to the frontend as possible. But when you are providing domain-driven design, especially when you are an enterprise and you need to have authorization concept and who can see what, and in these cases, for us, REST or other, let's say, different communication technologies like gRPC or even Driven are better choice, because you have a stabilized model and you know what to expect and what to return. And then over this model, you can easily provide authorization rules, what needs to be removed or pre-checked. And GraphQL can be a part of BFF that can then query domain-driven microservices.
Yeah, I would say that GraphQL is definitely a future for frontend, because look, a lot of APIs that are exposed to frontend mostly have too much data, so they are big and clumsy and have a great toll on performance, or they don't have enough data, so you have to query several APIs, which is even worse than you have a lot of network latency. So yeah, for frontend, definitely, I think that it's the future. But
okay, so we have another question regarding GraphQL. How do we handle GraphQL with microservices?
Okay, I know that well, currently we are, let's say, focused on the backend services, as we are trying to provide clean code and clean architecture there. I know that at some moment in time I piloted, I think it was Apollo framework that had this kind of support on microservice level, where it can consume a different microservices and then do the GraphQL processing over it. So perhaps you can check that framework to see if it works for you. Currently, we are not using it.
Okay, Mario is asking, how large are the teams and how do you break down big organizational goals to team product stories?
Okay, yeah, that's an interesting question, definitely. Actually, our entire company is now, let's say, in an agile transformation. We went from a standard way of doing projects, which was basically waterfall. You have marketing that thinks of an idea, they do a specification, it goes to IT implements. Now we're transferring to the agile way of working, where we have sort of a matrix organization. We have agile tribes that are in charge of larger domain, with squads inside that are in charge of smaller domains. So that's what we are doing on the level of the entire organization. And when we connect that to the architecture, what we want to do is have one squad in charge of one microservice. That's our goal. So the tribes handle the backlog when it comes to functionality, capabilities, stuff we want to do. When it comes to development, you have squads that are in charge of each squad in charge of one microservice, and that's how we want to achieve that. But we are in a setup phase now. So
okay.
Yeah.
Martina is asking, can you share your software stack? Which databases are you using?
Basically, I put stack on one of the slides. We are trying, currently we are using Postgres and Neo4j for some cases.
Yeah.
Okay.
We have a lot of Oracle databases in our legacy stack, but for all new stuffs, we are using Postgres and also Graph databases.
Okay, what approach you use for performance and integration tests in microservices distributed architecture?
So we are relying on mocks here regarding the integration test. So of course, I mentioned that we always have user acceptance testing that is done by testing team. But when you are developing, for us, great technologies were test containers, where you could mock a database, and also WireMock, because most of our integrations are based on either SOAP or PL/SQL. But this cannot replace the real end-to-end testing, but it can speed up the development because you don't need to be, let's say, you don't need to create test users fitting for some of the needs that you want to test. You can just set up a test container with test database and then put some your own test data values, or set up a WireMock that is returning what SOAP service should return.
Okay, so Mario is asking, how do you do public APIs in microservice environment? Does every team own their own public API, or is there some common part?
So currently, we don't have public APIs that are, let's say, published to the entire world. Most of our APIs are published either to our self-care applications or to our business partners. So this is something where we don't have much experience with. Luka mentioned how we are owning the APIs, but they're usually consumed by our own applications and not by a public.
Okay, so you said Spring Boot app doesn't equal microservice. What technologies do you suggest to use?
Yeah, I can answer that. We are using Java Spring Boot actually, but what I meant was it's not enough just to implement an application in Java Spring Boot to call it a microservice. To implement a microservice in Java Spring Boot, you need to have a Java Spring Boot app. You need to have a database with data. You have to expose APIs on that microservice, and that microservice should encapsulate one specific domain that is connected to a business domain. That is what a microservice is. So feel free to use Java Spring Boot, you use it also, but it's just that a lot of times people build Java Spring Boot applications, expose an API, but they have no data. The Java Spring Boot application queries a lot of different systems for data, and this is not a microservice. This is a proxy. You can implement it with whatever technology, but microservice should own its own data. That's what.
I mean, we also have the pattern that is not owning the data, because, as I mentioned, we have technologies or systems that are purchased, the billing system, mediation system. So you don't want to say now, okay, let's throw billing out of the portfolio and do our own billing. You don't do that. But if you are consuming data from billing and you want to create microservice that is not real microservice by Luka definition, but you want to go as closest to the data as possible and then provide your own business rules, again, business rules exposed to a standard business rule solution, and then expose this to the outer layer. But if you just create a Spring Boot app that is consuming some legacy API that is going God knows where, then you have that multi-layer flow that you really want to avoid.
Yeah, and you are not scalable. It doesn't matter how many microservices you deploy, because it still queries the one single database, for example, billing system for data. So that's your bottleneck and single point of failure. If that goes down, all of the microservices doesn't work. Doesn't matter if you have 1 or 100. So in order to build really scalable, microservice has to have its own data. But as Ivan says, you clearly can't do that every time. So there are those patterns where you connect to legacy systems, but connect deeply enough to data adapters and with as little layers as possible.
Okay, so we have our last question coming from Portugal. Hello from Portugal, great talk. How do you deal with scalability of software from vendors, or do you avoid using software that are behind licensing?
Okay, we use vendor software definitely, and we use some licensed software also. In telco, there's really a lot of domains, and for some you have excellent out-of-the-box vendor software that you can use, and it really doesn't make sense to invent the wheel and implement
your own billing.
Implement 20 microservices that does telco billing, for example. Then you should use you use a vendor solution, you pay the license, and when it comes to scalability, those software can be scalable. You can create a cluster, deploy several instances, and that's let's say a well-known approach how you can make monolith software highly available.
But basically, you should also look at the who is consuming and how much the data. So, for example, the usage consumption API that I mentioned, it is connected to a billing system that is purchased without a code solution. So, if you can query data from billing, then put it in a short-term cache or even a long-term cache, because you see that this data won't be changed regularly. For example, we have SAP that is containing our bills that users pay. So if you once query the paid bill, you know the amount, you know when it was paid, you can put it in cache. If user comes and queries, he wants to see his last 12 bills or some aggregations, I don't know, average bill amount for last 12 months, you don't need to query SAP. You can have it in your cache and query the cache or in-memory storage. In this case, cache is more like in-memory storage than a real cache. So it's dependent on scenarios. You try to find how data is used and how often data is changed on the backend, and then you made a wrapper around that can make your life easier, where you don't need to go directly to the backend and you don't need to scale it that much.
Okay. A lot of questions today. Thank you, Luka. Thank you, Ivan, for your time.